Well, it's taken months of work, but I'm really excited to share the modifications I've made to my B1 printer with you all. Now, all the modifications in this video are independent of one another, which basically means you can pick and choose what modifications you do on your printer, and it's not going to matter if you leave some out. Probably the most popular modification I'll be showing you how to do is adding a BL touch sensor to enable the use of auto bed leveling. We'll be looking at both the hardware installation as well as what changes need to be made in the firmware to enable this feature. After that, we'll get into some heavier modifying by adding an additional Z-axis stepper motor. This helps reduce any deflection on the X-axis rail. After that, we'll be looking at adding X, Y and Z cable drag chains for better cable management. After that, I'll be building a custom X carriage and then mounting an E3D Hemera Hotend along with a BL touch sensor and custom part cooling fan. Then to top it all off, we'll be adding a custom spool holder and filament guide tube. So if those mods sound interesting to your ears, then stick around because you're going to like this video. Now there'll be a link down in the video's description that takes you to my website where I will list all the hardware specifications for the modifications I've done. I'll have like the nuts and bolts, how long stuff is, how stuff is wired, like wiring diagrams and so on. So if you have any questions, check out the link in the video's description for that. Other than that, let's get right into the video.
Here we have the rare and elusive mechatronic Neanderthal. To attract a mate, this young single male must construct a functioning circuit. Unfortunately for this young male, he isn't using a custom printed circuit board, so there is only one way this can end. Oh dear. Thankfully this won't happen to you because you can order a custom printed circuit board from JLC PCB. Starting from as little as $2 for 5 PCBs, they have fast production time and offer a wide range of design options and colours to choose from. So why don't you try out JLC PCB for your next project? Your BL touch sensor should come with all the necessary hardware for installation. To install the sensor, you'll need to use the BL touch sensor bracket that came with your B1 printer. When tightening the screws, make sure to tighten them evenly, otherwise the sensor will be skewed to one side. When it comes to wiring up the sensor, you'll want to thread the wire through the cable sleeving for a neat and tidy install. However, since I'm going to be modifying my printer later in the video, I'll be using some jumper cables to temporarily hook up the sensor. From left to right, the wire colour is white, black, orange, red and brown. Since we'll be using the touch sensor as a Z-axis stop, we can unplug the Z-axis limit switch. Before the printer can use the touch sensor, we need to change some settings in the firmware, and unfortunately the settings we need to change cannot be made from the printer's touchscreen. To keep things simple, I'll provide a download link in the description for the firmware to enable the use of the touch sensor with your B1 printer. Just keep in mind that if you've changed any other settings on your B1 printer, this firmware will overwrite them. Download the firmware from the link in the description and extract the firmware.bin file. Now all we need to do is copy this file onto a micro SD card that has been formatted to FAT32. To flash the firmware to the printer, all you have to do is insert the SD card into the slot closest to the gantry and power on the printer. Upon startup, the printer will automatically install the new firmware. After a few seconds, you can power off the printer and remove the SD card as it's not needed anymore. The only thing left to do is to configure the probe offset. First, I'll heat up the bed and hot end to my typical operating temperatures. This is done because quite often a heated bed will warp compared to when it's cold. Make sure the nozzle is cleaned by removing any melted plastic from around the nozzle. From the menu, go to Configuration, Advanced Settings, Probe Offsets, then Z Probe Wizard. The printer will now home all axes. Once it's done, the screen will allow you to move the Z axis down by 1, 0.1 or 0.025 mm increments. Using the 1 mm increment, move the nozzle close to the bed without touching. Now choose one of the finer increments, slide a sheet of paper under the nozzle and slowly move the nozzle down until you feel it just starting to pinch the paper. With the nozzle just grabbing the paper, scroll down to Done, and don't forget to store settings before powering off the printer. To use auto bed leveling, choose the BIQU B1 ABL profile in Cura. This profile adds G28 and G29 commands, which makes the printer perform a bed leveling cycle before initiating the print. Now you're ready to smash out your first prints using auto bed leveling. If you'd rather compile the firmware yourself, then here is a quick rundown. First, go to the GitHub repository for Marlin, click on the code button, and click Download Zip. Next, scroll down the page and click on Marlin Configurations. Once again, click on the code button and then Download Zip. Now you need to extract both zip files. With that done, you can delete the zip files since they're not needed anymore. First, open the Configurations folder and open Config, Examples, BIQU, and then the B1 BL Touch. Inside this folder, you'll see configurations.h and configurations_adv.h. Now I'll open the Marlin 2.0 folder we extracted earlier, and then open the Marlin folder inside. Now we simply copy the configurations.h and configurations_adv.h. Now we need to open the Marlin folder in Visual Studio Code. Inside VSC, I have the Platform IO IDE and Auto Build Marlin extensions installed. From here we click on File, then Open Folder, then we select the Marlin 2.0 folder. From here we need to expand the Marlin folder and double click on configuration.h. From here we can see most of the settings for your B1 printer. Now we need to change a couple of settings in here. Using the Control F function, enter in the search bar use_probe. On line 917 you'll want to uncomment use probe for Z homing. The next setting is on line 1595 and you'll want to uncomment Z safe homing. With these changes made, we now need to compile the firmware before we flash it to the printer. To compile the firmware, I'll be using the Auto Build Marlin extension. From here we just need to click on Build and wait for the firmware to compile. Once it's finished, click the little folder icon to view the location of the compiled firmware. You should now see a file called firmware.bin. Now all we need to do is copy this file onto a micro SD card that has been formatted to FAT32. Flashing the firmware is the same as before. Insert the SD card into the slot closest to the gantry and power on the printer. Upon startup, the printer will automatically install the new firmware. Since I'll be installing an E3D Hemera, I'll remove the stock Hotend and filament stepper motor. This stepper motor will be getting upcycled into an additional Z-axis stepper. I 3D printed a stepper motor mount and attached the stepper using M3 screws. The motor can then be attached to the printer. I won't be using the factory wiring loom, so I chopped out a stepper motor connector and wiring to wire up the extra Z-axis stepper motor that we've just added. To connect the wires to the control board, I crimped on a 4-pin DuPont connector. Ideally, I'd recommend you buy JST connectors, since this is the type of connector the control board uses. However, I didn't have any JST connectors on hand, so I'm making do with what I have. If we take a close look at the control board, we can see a vacant header next to the Z-axis stepper connector. Conveniently, this board has two headers for Z-axis stepper motors, So all we need to do is plug in our extra Z-axis stepper motor into the empty header. Next, a lead screw nut is installed into the Z-axis lead screw mount. Longer screws are installed onto the factory Z-axis plate, along with 6mm spacers are installed before attaching the lead screw mount. A coupler is installed onto the motor, followed by a length of 8mm lead screw. And that is the Z-axis stepper mod complete. I've chosen to use the Hemera because of its lightweight and compact size. It's a direct drive Hotend which also claims to work really well with flexible filaments. The Hemera can heat up to 285 degrees Celsius, which is hot enough to mount any filament I will be using now or in the future. The factory X carriage is a little small for the new Hotend, so I'll have to make my own. We can use the same hardware and V-wheels from the factory X carriage. I'll include a download link for this template. I used a glue stick to stick the template to a sheet of 3mm alloy. After centre punching the holes, it was drill time. Since filming, I have updated the template to include hole sizes to avoid any confusion. Next, I used a bandsaw to cut out the template. Next, these arms have to be bent over at a 90-degree angle. Next, the V-wheels were fitted to the new X carriage and test fitted onto the rail. Since the new X carriage is wider, the X-axis rail is too short to allow for full travel, so I purchased a length of V-slot rail. Next, I had to transfer the hole locations to the new rail and drill them out. One thing that makes this job slightly tricky is removing the material from around the hole to allow room for the cap screw head. First I drilled the holes with a 5.5mm drill bit. Then I used a 10mm carbide burr to cut a relief for the cap screw head. There is also a couple of extra reliefs that need to be cut out on the back of the rail. Lastly, I tap the end of the rail to M5 thread. Later this will be used to mount the limit switch. Now the Hemera Hotend can be mounted to the new X carriage with 6mm spacers. The X carriage drag chain mount is attached to the carriage using M3 screws. Then the X-axis drag chain is attached to the mount. To attach this drag chain mount to the chassis, first the heater bed wiring needs to be removed. After passing the wires through the drag chain, the chain can be connected to the mount. To mount the bed drag chain, a hole needs to be drilled through the carriage. And with the drag chain connected, the Y-axis drag chain is done. Now I moved on to mounting the Z-axis drag chain. With all the drag chains mounted, the next thing I moved on to was gluing the touch sensor and fan duct pieces together using Grip 16 glue. Since this part will be located close to the Hotend, I recommend printing the parts from ABS, since ABS can tolerate higher temperatures before distorting. Once the glue cured, I mounted the duct to the Hotend. Now the BL touch sensor is mounted. When it comes to wiring, it's pretty hard to follow what I'm doing on camera, so I'll provide a wiring diagram to download to avoid any confusion. In a nutshell, the wires for the touch sensor, stepper motor, Hotend and fans all need to have extension wires soldered to them. To keep things looking tidy, I used some cable sleeving which had the added bonus of making it easier to thread the wires through the drag chains. With the addition of the BL touch sensor, the factory Z-axis limit switch is now redundant, so we can remove it and upcycle it into an X-axis limit switch. The X-axis limit switch has two threaded brass inserts installed. An M4 screw is installed onto the X carriage to bump the limit switch. With that done, the wiring is fed through the drag chains. Now all I had to do was wire everything up to the control board. With the wiring done, I moved on to making a new X-axis drive belt since the old one is too short. At the end of the belt, I folded the belt back on itself and then used a zip tie to secure the fold. The belt is then installed onto the X carriage and threaded around the stepper and idler. The other end is secured using the same zip tie method. Now I moved on to making the spool holder. First I cut a 150mm length of 20x20 V-slot rail and drilled an 8mm hole at one end. I printed the spool holder screw that I found on Thingiverse. Shout out to Forever Winter for sharing this design. I'll leave a link to this part on Thingiverse down in the description. The spool holder has a bearing installed at each end. A length of 8mm threaded rod is used to mount the spool holder to the rail. To mount the spool holder to my printer's chassis, two V-slot rail brackets are used. With the spool holder done, the last thing to do was to make a filament guide tube. First I picked up a 4mm pneumatic compression fitting. This fitting is used to hold one end of the tube. I grabbed a length of alloy flat bar and marked out where I needed to drill a hole and round the end over. The hole is tapped to allow the pneumatic fitting to be screwed in. Then the bar is bent at a 90-degree angle. A V-slot nut is slid into the top rail, then the filament guide is attached. The tube is pushed into the fitting and lastly into the extruder.
And that completes all the modifications I've done to my B1 printer. It took a long time, but I'm really happy with the result. If you found the video useful, please smash that like button because this took an enormous amount of effort to put together. And also consider subscribing for more videos just like this one. Thanks to my Patreon supporters for your continued support, and I will see you in the next video. Bye for now.